Survey of the universe. In order to understand the universe, it needs to be surveyed. Astronomers use various methods to measure the vast distances between stars and galaxies, and to study the behavior of these remote objects. If two objects radiate with the same intensity, luminosity, then the closer object will appear brighter. If a star's actual luminosity is of a known magnitude, then it can be used together with the observed brightness to calculate how far away it is. Although actual luminosity is not always obvious, astronomers are able to determine this value for certain stars, known as standard candles, and use it to estimate their distance from Earth. Examples include Cepheids, which are giant bright stars that pulsate regularly. Their fluctuation periods are dependent on their size and luminosity. These pulsations can be measured and provide useful information about the distance of a galaxy. White dwarf stars that explode as extremely bright supernovas in binary star systems can also be used as standard candles. Their observed brightness can be used to estimate the distances of very remote galaxies. Redshift. Starlight can be partitioned into its prismatic colors using a spectrometer, much as sunlight is in a rainbow. However, chemical elements in the gas layers of stars absorb light of certain wavelengths, causing dark absorption lines to break up the spectrum. Almost all galaxies have absorption lines that are shifted toward the longer, red, wavelengths. The redshift effect is greater the farther away a galaxy is. This relationship can be explained by the expanding universe. As space itself expands, the wavelengths of the light are stretched. The longer light travels through the universe, the more its waves are stretched. Therefore, if the redshift of a galaxy is known, its distance can be calculated. This relationship is known as the Hubble constant. Of course, the interpretation of the redshift needs to be correct, and the expansion rate of the universe must be known as precisely as possible. There are also other effects that can cause a redshift, for example when a galaxy in space is moving away from us. However, this is not enough to explain redshift in general, because it implies that our galaxy is somehow special, in that other galaxies are moving away from us but not from each other. It has also been proposed that light would lose energy on its long path and perhaps turn more red for this reason. So far, however, no generally accepted explanation for redshift has been found.